this video, we're talking about inscribed angles of circles. And when we talk about an inscribed angle, we're talking about an angle that has its vertex on the perimeter of the circle, and the edges of the angle are chords of the circle. So if we take, for example, this angle here, angle BCD, it would be an inscribed angle because its vertex is here at C, and C lies on the circle. So its vertex lies on the circle, and the edges of the angles, which are the line segment here BC and the line segment CD, are chords of the circle. Remember that a chord is a line segment that has its endpoints on the circle. So chord here BC has its endpoints on the circle, and chord CD has its endpoints on the circle. Therefore, the angle BCD is an inscribed angle in the circle because its vertex is on the circle and the edges of the angle are both chords of this circle. So in this particular example, we've been given circle A, which means we've been told that this circle has its center at A. We've also been told that the measure of arc BD is 60 degrees. So if we find arc BD here, it's this arc that starts at B and ends at D. The measure of that arc is 60 degrees. So let's go ahead and indicate that. We've also been told that the measure of angle ECD is 40 degrees. So if we find here E, C, and D, so this angle right here is going to be 40 degrees. We know also that line CD is a diameter, so CD here is a diameter. And we've been asked to find various angle measures and arc measures that relate to this circle. So before we go ahead and go through this list, let's figure out what else we can label on this circle based on what we know about inscribed angles and interior angles of circles. So the first thing we can look at is the Isosceles triangle theorem. If we go all the way back to the Isosceles triangle theorem, remember that it tells us that when we have two congruent sides of a triangle, the angles opposite to those sides are also going to be congruent. So because this is a circle, I know that AC is a radius of the circle because A is the center and C is on the circle. Since E is on the circle, I know that AE is also a radius, which means that these two sides here, AC and AE, are going to be congruent. They're both the radius of the circle, so they're going to be equal to one another. That tells me that opposite angles of this triangle, triangle ACE, are also going to be congruent, so I can go ahead and say that this angle, angle AEC, is going to be 40 degrees because this angle is 40 degrees. And then remember that I know that the three interior angle measures of a triangle are going to sum to 180 degrees. So if I take 40 and 40, I'm going to get 80. 180 minus 80 gives me 100, so I can say that this angle measure here, angle CAE, is going to be 100 degrees. We've also talked before about interior angle measures of a circle, and at the beginning of this video we talked about an inscribed angle, which would be angle BCD, where the vertex is on the edge of a circle. So when we talk about an inscribed angle, the vertex is on the circle. When we talk about an interior angle, the vertex is at the center of the circle. So angle BAD would be an interior angle because the vertex is at A and A is the center. So angle BAD is an interior angle, and one thing we know about interior angles is that the angle measure is going to be the same as the degree measure of its intercepted arc. So angle BAD has an intercepted arc of arc BD, and we know that the measure of arc BD is 60 degrees, which means that we can also say that the angle measure of BAD is going to be 60 degrees because these two are always going to be the same. Now from this point, what else do we know? Well, we've been told that line CD is a diameter. So CD is a diameter, which means that angle BAC, this angle right here, and 60 degrees are going to be supplementary. So I can say that 180 degrees minus 60 degrees gives me 120 degrees. So 120 degrees I can label here as angle BAC because I know these two angles are going to be supplementary. In the same way, I know that these two angles right here are going to be supplementary because they're on one side of a straight line. So 180 minus 100 gives me 80, so I know this is going to be 80 degrees. Here I can come back to the Isosceles triangle theorem. Remember that we know that the radius of a circle is always going to be the same, and AD is a radius, so I can say that AD is going to be congruent to AE and AC. Well, if these two sides are congruent, then I know that these two angle measures here are also going to be congruent, and I know that the three interior angles of a triangle sum to 180 degrees. I already have this 80 degrees here, so if I take 180 and I subtract 80, I'm going to get 100. Because I know that these two angles are going to be the same, I just divide 100 in 2 and I get 50, so I can say that these angle measures are 50 degrees. I can also bring the isosceles triangle theorem over to triangle ABC and say that line segment AB is congruent to line segment AC. These two are congruent. Therefore, by the isosceles triangle theorem, angle ABC and angle ACB are going to be congruent. So I take 180 degrees, the total of the interior angle measures of a triangle. I subtract 120, I'm going to get 60. Then I just divide that by 2, and I can say that these angle measures here are going to be 30 degrees. Now this brings up an interesting point. Notice that this angle measure here, angle BCD, the angle we talked about in the beginning as being an inscribed angle, it's 30 degrees. Well, there's something interesting to know about inscribed angles. The measure of an inscribed angle is always going to be half the degree measure of the intercepted arc. So if I take angle BCD, I know it's an inscribed angle. Given the fact that I know that the degree measure of arc BD is 60 degrees, I can just divide that by 2, and I could have said right away that angle BCD was going to be 30 degrees. Similarly, if I had been told that this angle was 30 degrees, I would have been able to say right away that the degree measure of arc BD was going to be 60 degrees, because I know that the degree measure of the arc is always going to be twice the degree measure of the inscribed angle. So I've got all of my interior angles. Now what about the degree measure of each arc? Well, I already know that this arc is 60 degrees. Remember that an arc is always going to be equal to the interior angle measure. I know that this angle measure is 120 degrees, so I can say that the degree measure of arc BC is also going to be 120 degrees, because the degree measure of the arc is always going to be equal to the degree measure of the interior angle. Same thing here, I know that this is 100 degrees, so I'm going to say this is 100 degrees, and this is 80 degrees, so I can say this is 80 degrees here. And just to double check myself, the sum of the degree measures that make up all of the arcs around the circle should be equal to 360, so I can say 120 plus 100 gives me 220, plus 80 gives me 300, plus 60 gives me 360. So now that we've got everything labeled, let's go ahead and fill in what we've been asked to find. We've been asked to find the measure of angle BCA. So we'll go ahead and find BCA, and we can see there that that's 30 degrees, so 30 degrees. We've been asked to find the measure of angle ABC. So ABC, that's also going to be 30 degrees. Angle BAC, we already know that that's 120 degrees. And then the angle measure of BAD, so BAD is going to be 60 degrees. The measure of arc CBD, so CBD, if I find CBD, I can say 120 degrees plus 60 degrees is going to be 180 degrees. The measure of angle CED, so CED, I would just have to sum these two angles together. 40 degrees plus 50 degrees is 90 degrees, so 90 degrees for that angle. The measure of arc BC, so the minor arc BC, I already know is 120 degrees. The measure of arc ED, so ED I already know is 80 degrees. The measure of arc EC, that's the minor arc here, 100 degrees. And the measure of angle EDC, so EDC, I know already that's going to be 50 degrees. So I've already found everything that I've been asked for just by labeling the circle using Isosceles triangle theorem, the fact that the interior angle measures of a triangle sum to 180, and what I know about inscribed and interior angles of a circle.